Okay. This video, we're going to take an Excel spreadsheet, and I've just started making it up right here. And we're going to do the same problem we did by hand, except this time we're going to do it with technology. And you're going to see that, one, I did mess up the last problems, and two, technology does help you out tremendously. So let's go ahead and work this problem. Here we have our ages 18, 18, 19, 21, 25, and 36. Add those up, you get 137, and that's where I messed up. I had 167 because I can't add, and I'm videoing, and I had a mistake there. Divide it by 6, and that'll give you 22.83. Now, we've got our mean. Now subtract the mean from each one of these. Remember, we need to lock the mean right here. And any of you out there that's familiar with Excel, if I click and drag down here, then it's going to assume that I'm taking this number, subtract that number, this one, subtract the next number, this one, subtract the next number. So I don't want to do that. So what I do is I lock, hit F4, and I lock this number right here. And I hit enter, and it will subtract. Well, I thought I did it. Oh, I know what I did now. Sorry. Equals this number minus this number, and hit F4. There we go. And there's your numbers. And copy that down. And there's your numbers right there. Now we're going to square those numbers. So equals this number raised to the second power. And you can copy and drag that down because it's going to read each one and square it. And there's your numbers there. Okay? Now we need that number summation. So put that button right there. Click on those. And there's your number there. And this number should be D10. Sorry. Divided by D10. And that number should be, their X bar should be, no, variance should be this number divided by n minus 1. So x minus x bar quantity squared over n minus 1, so that's going to be this guy minus 1. And that doesn't look right. D10, let me just erase this because I think I've got a wrong formula in there. Equals this number divided by parentheses n minus 1. There, that looks a whole lot better. And then take the square root of that, and that will give you this number here. 6.967. 22 and 7. So there's your 22. Add 7 on both sides, or I'm saying 7 is a whole number, but you do your calculator with the decimals, and this is your curve. And it's showing you the curve, and 95% falls between 9 years old and 37 years old. That's your calculation. And I apologize for mine being off. But it was based on the average coming up to be 28, and this is the difference right here, 22, so I made a mistake on that one. And hopefully that'll help you work through that one. Now, if you make several of these spreadsheets, n is equal to 5, n is equal to 6, n is equal to 7, n is equal to 8, 9, 10, and 11, then all you got to do is punch in the numbers based on how many numbers you have, you punch these numbers in right here and it will calculate everything for you. So that's something, you know, you can work on if you're an Excel geek like myself. You can work on this all day long and make all kinds of different applications. So if I go back and I change this to 1, 2, 3, 4, 5, 6, then I have the mean of 3.5 and the standard deviation 2 to the right and 2 to the left. So, you know, however you want to do it is up to you. A lot of people use the Excel spreadsheet because they like it. I'm one of those people. I would much rather use an Excel spreadsheet to teach a class because it actually shows you what I'm doing by hand, what we did on the paper a while ago, and it also helps you minimize careless mistakes like I did on the video. So let's move on to another one. Frequency distribution. This is the mean and standard deviation of a data-driven set. I'm going to highlight these a little bit for you. I think I'll keep them black, but I think I'm going to highlight those maybe up. Those numbers right there represent a class or a population. Data-driven. In other words, you've got 6 pieces of data right here, and you do it the old-fashioned way of by hand, finding the standard deviation as well as the mean, taking that mean, putting it in the middle, and adding 2 standard deviations and subtracting 2 standard deviations. Anytime you're dealing with test scores, measurements, anything like this, then you are dealing with a data-driven set. Sorry about that. Okay, next is your frequency distribution. The problem that we did with the frequency distribution is as follows. 50 to 69, 70 to 89, 90 to 109, 110 to 129, and 130 to 149. And that's our classes. And then we have our F, which is our head count of 2, 33, 35, 7, and 1. Now, as I told you, this right here doesn't really help us very much. I'll go ahead and make these bold for you. These are not very helpful, so we've got to find something, a number, that represents these classes that I can calculate with, and that number is X, which is the midpoint. And I'm going to go ahead and just type in the first one, and we'll use the class width for the other calculations. So parentheses 50 plus 69, close parentheses, divided by 2, and there's your first. And now you just take this number and add the class width, which the class width, if I can find the plus symbol, the class width is 20, because 70 minus 50 is 20, 90 minus 70 is 20, 110 minus 90 is 130 minus it. In other words, if you subtract vertically, 89 minus 69 is 20, 109 minus 89 is 20, and so on. You're going to get 20. That's your class width. And there's, and you just copy down, and you should get those numbers there. So now you've got a midpoint, and you have X and F. Our formula for mean is to take F times X, add it up, multiply it, then add it up, and divide by N, which in this case is, let's go ahead and find N. N is equal to, and then summation of all of these. I think we said 78, and yes. there's your, we'll make that bold, that's important. There. So f times x, right here. F times x. And this is when the spreadsheet is so helpful, because all you got to do is pick and choose, and equals f times x, and copy that down, and you'll see your numbers is going to be, let's see, let's check the star numbers. 119, that's good. 26, 23, that's the one I fixed. 3482, yeah, that one was way off, and so on. Let's see if I can find the other one. I can't remember if I fixed that or not. Yeah, there it is. 2330. Yeah, that was way off. 34. Yeah, I had several things wrong on that one, so might just want to erase that one. And that's our numbers there, and that's f times x, f times x, f times x, f times x, f times x. And we need an x squared, so I'm going to go over here to the, I'm going to skip a line, and I'm going, or column, and I'm going to put x squared here. And the reason I'm doing that is because I don't want to confuse this material with what I'm doing over here. So I'm going to inline that and do that, and we will do x squared now. Sorry, I had to reply to an email. So that's equal to x quantity squared, and that's those numbers, those big numbers that we were talking about. And then I'm going to need a summation of that. Oh, we got to do x squared times f. So let's do f times x squared, and that's going to be equal to f times x squared, and that's going to be your big numbers. And we need a summation for both of these. This number right here, we need that, and we need this. And let's make those bold, because we're going to use them in a calculation. Now, the formula for the mean, so we're going to call this mean parentheses of a frequency distribution is equal to, well, I don't like to use that equal. Oops. Mean of a frequency distribution is equal to, and we're going to go right here, and it's equal to the summation of f times x, right there, divided by the summation of x. And there is our mean of our IQs, or whatever IQ scores. There's the average. About a 92 IQ score is average. Now we got to find the standard deviation. Well, in order to find the standard deviation, you have to, standard deviation of the frequency distribution is equal to, well, I'm going to draw this out a little bit, n, well, that's equal to this guy, times summation of f times x squared, which would be this right here. And those two go together. So we will make those two dark. And then subtract, and I'm just going to put subtract. That means it's just a word. And this number squared. So equals this number raised to the second power. And all of this is over n times n minus 1. So, move this over a little bit. This right here is your standard deviation. N times the summation of f times x squared minus the summation of f times x quantity squared over n times n minus 1. So I'm going to bring it down a few lines and I'm going to do some of the math for you. Standard deviation of a frequency distribution is equal to, and let's go ahead and take these two numbers and I'll highlight them blue, and we'll make that this blue, and that's going to be equal to this guy times this guy, and there's that number. So I'll make that bold and it's blue, so you know that this number goes with these two right here, multiply. Oh, excuse me. Let's stop yawning. And to subtract, it comes down. Control C, Control V, and then this number comes down also, equals this number, and I'm going to highlight that as color. Let's make it that color right there. And then over, we'll take these two numbers and we'll give that a maybe a greenish color. No, not green. I like use green except for the answers. So we'll make it kind of a new, let's do dang old pink. There we go. Alright, and that'll be this number right here. And that's equal to 78 times 77. And here's our three numbers that we need to work with now to get our standard deviation. And we're going to take the square root, so it's not a big deal. So Control C, Control V, and that's equal to this number minus this number over this number. And now finish it out, or the variance. I'm sorry, I should be calling this the variance, but I don't really care about that right now. Divided by this number, and that is our variance. Okay, so I'm going to go back up here and I'm going to put variance equals now, if you want to find the standard deviation, you just take the square root of the variance. And that's equal to this raised to the 0.5 power. And there is your standard deviation. And we'll color that green because that's important. And where's our name? And this is important. So now that you got those two numbers, you can do your basic bell curve. I'll do it down here. Equals the mean and two standard deviations equals the mean plus standard deviation, and that's equal to this plus the standard deviation. and equals this minus the standard deviation, and equals this minus the standard deviation. And there is your 95% of data falls between this IQ score of 63 and 122. And I'll make this color. Let's make it kind of a light green color. And that's how you find your mean and your standard deviations by hand, which I kind of messed up on a couple of them, and how to find it with the Excel spreadsheet. And I hope that helps. I thought I stopped it. Sorry.